Okay, for today's e-learning, you're supposed to be getting mastery on Unit 2, Swyk 2. And in just in case you need some extra help, this is a video tutorial that will help you do some of the problems that are on there. So when you do the Swyk, you're going to see some graphs sort of like this. And you have to be very careful and make sure you're looking at whether it's a position time graph or it's a velocity time graph. And it'll ask you lots of different things like what's the slope, what's the intercept, what's the equation, how is it moving, that kind of stuff. So for this one, this is a position time graph, x versus t, and I've got this line on it. Now it looks like the line is kind of going downhill, but that doesn't really tell me a whole lot. Let's say the question asks, what's the intercept? Well, the intercept is right here where it touches the vertical axis, and in this case it's a position. And so if I said that the intercept was 8, that would be wrong. The y-intercept is not just 8. I have to put units, and that would be 8. And if you look at the position, it's measured in meters, so I'll say 8 meters. Okay, what's the slope? Well, you know from slope, you know from math class that slope m is given as the rise divided by the run. Well, for this particular one, if I start here at 8 and I go to the next dot, which is at 5 here, it's 1, 5, the rise is actually a -3. So when I find the slope here, I end up getting -3. But it's not just -3, it's really -3 meters. And then I have to divide that by the run, and the run in this particular one happens to be 1. But it's not just 1, it's 1 second. So what does this simplify to? Well, the slope simplifies to, in this case, -3 meters per second. Oops. Okay, so now I can go ahead and write an equation, because in math class we know that the equation for this line is given by y equals mx plus b. But if you say that that's the answer, well, you're wrong, because you have to plug in what m, x, b, and what y is. So if you say y equals -3 x plus 8, you're still wrong. That's not right, because it's not really 8 and it's not -3. If you say, well, okay, the y-intercept is 8 meters, and you're like, okay, the slope, I get this, the slope is -3 meters per second. And so my equation must be y equals -3 meters per second times x plus 8 meters. You're still wrong. You're getting closer though. Look at the y-axis. The y-axis is not y in this case. In math class, the vertical axis is y. But in physics and science, the vertical axis represents something. It has some kind of meaning. And if you look at the vertical axis, that's position. And instead of using a p, we're going to use an x for position. So over here, the y is really going to be x, the position. I could have used any variable, but traditionally we use x because if you think about this like being a buggy or something, the buggy moves along the floor, and that's horizontal, and we usually call the horizontal x. So then the question becomes, well, what is this x then? Well, in math class, the horizontal axis is x. Well, the horizontal axis is not x in science class. If you look at this this horizontal axis, it's called time. Let's use the variable t though. So the equation for this graph is x equals -3 meters per second times t plus 8 meters. And so that would be the equation of this buggy or whatever it is. So what's the meaning of this? Well, the meaning is that it starts at 8 meters. That's where it starts at. and it's moving in the negative direction. At 3 meters per second. Or 3 meters every second. And I think I'll move this over here so we can see it better. So that's really the meaning of it. And so it's going at a constant velocity in the negative direction. So if I had to describe the motion, I would say, so describe motion verbally. I would say starts at 8 meters and moves in negative direction at a constant speed of 3 meters every second. That's it. Okay, so then sometimes we have to look at velocity time graphs. So let's draw the velocity time graph for this. Well, remember we just said it's moving at 3 meters per second, or 3 meters every second, but in the negative direction. So that means it has a constant velocity. So I am going to draw a constant 3 meters per second every second constant velocity. But that's not right, because that would be a positive 3 meters per second. I need this to be a negative 3 meters per second. And so if you saw a graph like this, you would describe the motion as, you'd say, it moves in negative direction at a constant speed of 3 meters every second. So it wouldn't look like this. Let's talk about some other ones. Let's say we had something like this. And this does not go with the previous graph at all. Okay, so let's say we had a graph that looks like that, and it's a velocity time graph. Describe this motion. Well, if I wanted to describe this motion, I would say it speeds up in the positive direction. Or let's say I had a graph that looked like this, and again we're dealing with just velocity time graphs. Let's say it looked like this. I would say that in this case it slows down in the positive direction. It's still moving in a positive direction because all these speeds are above zero, so they're all positive, but it's slowing down. Or let's say I had something like this. In that case, I would say it speeds up in the negative direction. Or let's say I have something that looks like that. Well, that would be it slows down in negative direction. Anyway, so there's lots of different possibilities. If we had a position time graph that looks a little different than this, so let's say, so ignore the line that's on here. Let's see if I can erase it or something. Let's get rid of the line if I can. Great. So let's say we have some kind of graph that looks like this. And I'm just going to make something up here. So if we had a graph that looked like this, remember it's a position time graph. Now for this one, notice it stays at 5 meters. If I had to describe the motion for this one, I would say starts at 5 meters and doesn't move. If it was something like this, I would say for this one, it starts at 5 meters and moves in negative direction at constant speed. Or let's say I have something like this. For this one, I would say it starts at negative 3 meters and doesn't move. Or let's say I have a graph that looks like this. I'd say it starts at negative 3 meters and moves in negative direction at constant speed. Or maybe it looks like this. I'd say it starts at negative 3 meters and moves in positive direction at constant speed. So remember, the slope of this graph, the position time graph, gives you the velocity. The steeper it is, the faster it's moving. So hopefully this helps you out a little bit.